Welcome to Algebra 2, Unit 6, Lesson 9, Practice Problems. Which statement is not, I want to underline, not true for the function given by f of theta equals sine theta? So remember that sine theta is referring to the y values. For values of theta between 0 and 2 pi. So we're talking from the starting point on the right side of the circle, counterclockwise all around back to where you started from. So A, the outputs of the function range from -1 to 1. This is true. -1 at 3/2 pi, that's or, yeah. So the y value is -1 at 3/2 pi, which is the bottom of the circle, and it's 1 at 1/2 pi. That's the top of the circle. So A is true. B, sine of theta equals 1 only when theta equals pi over 2. This is also true. This is the top of the circle. C, sine of theta equals 0 only when theta equals 0. Well, the sine of theta is 0 when you're on the x-axis. And this not only happens at 0, but it also happens at pi. So C is the one that is not true. Choice D says sine of theta is greater than 0, so positive. For 0 not included, to pi not included. That's true. This is the top half of the circle. And on the top half of the circle, y values are positive. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Angle theta measured in radians satisfies cosine of theta equals 0. Remember that cosine of theta is your x value. What could the value of theta be? Select all that apply. So x equals 0 on the y-axis. So cosine theta equals 0 at the top of the circle and at the bottom. So at the top of the circle, the radian measurement is 1/2 pi. That's choice C. At the bottom of the circle, the radian measure is 3/2 pi. And that's choice E. All three other choices have values that are not 0. At 0, cosine of 0 equals 1. At pi, cosine of pi equals -1. And at pi over 4, the cosine is 0.7. Remember to ensure when you go in to use your calculator that it is set to radians, not degrees. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Here are the graphs of two functions. Graph 1 is the blue line, and graph 2 is the green line. Number 1. Which is the graph of y equals cosine of theta? Explain how you know. Cosine is the x value, and at cosine of 0, it equals 1. We see that on the graph, when x is 0, y is 1 for graph 2, the green line. So for number 1, graph 2 is cosine theta because when theta equals 0, x equals 1. For number 2, which is the graph of y equals sine of theta? Explain how you know. Well, this leaves graph 1 is sine of theta because when theta equals 0, y equals 0. And these are good things to remember. When you work with sine curves in the future, sine curves start at the origin or cross through the origin. Cosine graphs will start at 1. So if you can try to remember that now, it will help you in further trig lessons. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Which statements are true for both functions y equals cosine of theta and y equals sine of theta? Select all that apply. Choice A. The function is periodic. This is true. Both sine and cosine repeat themselves over and over. Choice B. The maximum value is 1. That is also true. Both cosine and sine will go between -1 and 1. So B is also true. Choice C. The maximum value occurs at theta equals 0. So true for cosine of theta, false for sine of theta. The maximum for sine of theta happens at pi over 2. Choice D. The period of the function is 2 pi. This is true. That's one time around the circle, and on a graph, the wave will repeat once every 2 pi. Choice E. The function has a value of about 0.71 when theta equals pi over 4. This is true. This is in quadrant 1. It is a 45-degree angle, so x and y have the same value, and they're both positive in quadrant 1. Choice F. The function has a value of about 0.71 when theta equals 3 pi over 4. 3 pi over 4 is in quadrant 3. Cosine of 3 pi over 4 is negative 0.71. In quadrant 3, the x value has a negative value. So F is false. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Here is a graph of a function f. The function f is either defined by f of theta equals cosine squared theta plus sine squared theta, or f of theta equals cosine squared theta minus sine squared theta. Which definition is correct? Explain how you know. The way that I figured this out is thinking about the value of pi over 2. Cosine of pi over 2 equals 0. So cosine squared of pi over 2 also equals 0. Sine of pi over 2 equals 1. So cosine squared of pi over 2 also equals, or sine squared of pi over 2 equals 1. So in the first model, we would have 0 plus 1 equals 1. And this point would be up here, which it's not. In the second model, we would have 0 minus 1 equals -1, and the point would be down here, which it is. So f of theta equals cosine squared minus sine squared theta, because at pi over 2, the output would be -1, and that's where the graph is. If you have any question about how I solved this practice problem, please use class time to ask for further clarification. Here is a graph of the water level height h in feet relative to a fixed mark measured at a beach over several days d. Number 1, explain why the water level is a function of time. In order to be a function, every input must have only one output. And in this case, every time has only one height. So it is a function. Number 2, describe how the water level varies each day. It varies by going from high tide to low tide to high tide twice daily. When we're looking at this, we see that high tide to low tide to high tide, this is one cycle, back to low tide and back to high tide, this is 2 cycles per day. And number 3, what does it mean in this context for the water level to be a periodic function of time. It means each day repeats a pattern of two high tides and two low tides. This is a periodic function, and it's a very important periodic function around the world for different reasons. People need to know when the water levels are going to be lower and when the water levels are going to be higher. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. The minute hand on a clock is 1.5 feet long. The end of the minute hand is 6 feet above the ground at one time each hour. How many feet above the ground could the center of the clock be? Select all that apply. If you look at a clock, the only points where there are not at least two of the same height would be at the very top of the clock and at the very bottom of the clock. Everywhere in between on the right side has a corresponding height on the left side. So if the minute hand is 1.5 feet long and the end of the minute hand is 6 feet above the ground, if the minute hand were pointed at the top, then the end of it would be 6 feet, and we would subtract 1.5 feet back to the center point, so the center of the clock would be 4.5 feet above the ground. So A is a correct possibility. However, if the hand were pointed down at the bottom of the clock, now the tip of the hand is 6 feet above the ground, and we need to add the 1.5 feet for the hand to go back up to the center of the clock, and the center of the clock would be 7.5 feet above the ground, which is choice E. If you have any questions about how I solved this practice problem or any of the practice problems on lesson 9, please use class time to ask for further clarification. If we have class time remaining, please use it to work on the digital SAT math modules. Remember, there is the incentive program from the school but it also counts for 25% of your grade in this class. So try to get as many skills proficient, which is light purple, or mastered, which is dark purple.